Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now in today's video, our focus is on topical review of two topics, that is representation of data and the next one is normal distribution. Now let's get started with this. Now these formulas are given over here. This is for representation of data and it is from the formula booklet MF19. Now the first question, let's read it very comfortably. The heights in centimeter of 11 basketball players in each of two clubs, Club A, Club G, is shown below. So this is the data for the first and this is the data for the second. The first part, state an advantage of using a stem and leaf diagram compared to a box and whisker plot to illustrate this info. Now when we draw a stem plot, the original data is preserved, is simply neatly arranged. That is the advantage. And if someone asks you what is the advantage of a box plot as compared to a stem plot, you would say at a glance you have a 5-point summary. That includes the lowest value, that includes the highest value, that includes the quartile, which means the lower quartile and the upper quartile, and that includes the median. The second part, represent the data by drawing back-to-back stem and leaf diagram with Amazons on the left-hand side of the diagram. Now this the examiner does so that everyone, the answers, they look the same. Amazons on the left, giants on the right. The stem will go over here, the leaf for Amazon, the leaf for giant, and make sure that it is of equal class width. The class intervals should be of equal class width. And naturally, there should be a key at the end. It's already made, so let's go to the mark scheme right away. This is for Amazons, this is for giants. The key is 1/18, 1/18. It means 181 centimeter for Amazons. And 18/2, what does it mean? It means 182 centimeter for giants. And that's how the data is arranged. You can have a single key or you can have two separate keys. That's your choice. Also, it's a good idea that we write the total in the bracket over here. That's 1 and that's 4 and that's 5 and that's 1. And over here, this is 1, this is 3, this is 3, this is 3, this is 1. So that we know exactly that this adds up to 11, this adds up to 11. Now the next part that they're asking is that find the interquartile range of this heights of player of Amazons. So there are altogether 11. 11 divided by 2 is 5.5. It's an odd number. Round it up, the median is the sixth value. That means the sixth value is in the middle. 5 values are lower than this. 5 values are greater than this. Out of these 5 values, the median is the lower quartile. Out of these 5 values, the median is the upper quartile. So let me just show you the working over here. So we have 1, 2, 3, 4, 5. This is the sixth value. That is the median. There are 5 values below it, 5 values above it. Now, out of these 5 values, 1, 2, 3, the third one is the lower quartile. Therefore, 182, 182. And out of these 5 values, the middle one, which is 202, that is the upper quartile. As simple as this. Upper quartile 202, lower quartile 182. The difference is 20. What's the next part? Now it says 4 new players joined the Amazons. Altogether, there were 11 in the beginning. 4 new joined up. So how many are there? 15. The mean height of the 15 players of Amazons is now 191.2 centimeters. The heights of the 3 of the new players are this, this, and this. Find the height of the 4th player. Now the very first thing that I did is that I took this 15. I multiplied it with 191.2. I get sigma x for 15 players. And for the 11 players who were the original 11s, I'll simply add all of these on a calculator definitely, and I add up to 2132. So the difference between these two is what? This is 736. This is the sum of the heights of 4 new players. We already have 180, 185, 190, and the unknown one is h. This adds up to 736. Therefore, the value of h is 181. Pretty basic stuff. Now let's move to question number 2. It says a summary of 40 values of x gives the following info. Sigma x minus k is 520. Sigma x minus k whole square is 9640, where k is a constant. Given that the mean of these 40 values of x is 34, find the value of k. That means x bar is 34. Now, first of all, it's a question of coding, also known as assume mean. So what do we do over here? Whatever is written over here, give it a new name, give it a new variable. I have given it y. Let y is equals to x minus k. Therefore, this is sigma y. Therefore, this is sigma y squared. And what I do is that I calculate y bar, which comes out to be a beautiful number, which is 13. Y bar is x bar minus k, because y is equals to x minus k. Mean is altered by addition or subtraction. Y bar is 13, x bar is 34, k as it is. Therefore, the value of k comes out to be 21. The next part. Find the variance of 40 values of x. That is the same thing as 40 values of y. So standard deviation square, that is variance. That is sigma y square over n minus y bar square. 9640 over 40, which comes out to be 241. 13 square, that's 169. The difference is 72. Standard deviation square for y, standard deviation square for x, that is also 72. The next one. The times taken in minute by 360 employees at a large company to travel from home to work are summarized in the following table. Draw a histogram to represent this info. There is time in minutes. There is the frequency. So therefore, this is frequency distribution. For histogram, we have to check the very first thing is that other class intervals or of equal width. This is 5, this is 5, this is 10, this is 10, this is 20. That means if it's of unequal width, what goes on the vertical axis? Frequency density. What is the definition of frequency density? Frequency divided by class width. So frequency divided by class width, that gives me this. 102 over 5 is this. 135 over 10, 76 over 10, 24 over 20, we get this. And then we have the frequency density on the vertical column, and on the horizontal column, we have the class boundaries. So now over here, this is frequency density. Of course, you do a bit of scaling, and we have all the bars over here. The first two bars have a width of 5, and then it's a width of 10, a width of 10, and a width of 20. Normal distribution. Let's look at question number 4. It says the lengths of leaves of a particular type of tree are modeled by a normal distribution. A scientist measures the length of a random sample of 500 leaves from this type of tree and find that 42 are less than 4 centimeter long. So let me highlight this. So first of all, there are altogether 500 and 42 out of 500 are less than 4. So 42 out of 500 are less than 4. And the 500 is still there, and 100 are more than 10 centimeter long. 100 are more than 10 centimeter long. So basically 42 over 500 is the probability. 100 over 500 is the probability. This is less, this is greater. Now what do we do over here? Since this probability is less than 0.5 and the limitation of normal distribution is that the minimum probability is 0.5. So what do? We flip the inequality and subtract the probability from 1. We flip the inequality and subtract the probability from 1. And now convert it into decimals, This is probability 0.916. So let's go over here and look for 0.916. 916 is somewhere over here. 9115 and this is 9131. So 9115. Let me pick this thing. And 916 means 9160. Actually, there it is. 9147. And let me add 13 over here. So therefore, this is 1.3 and this is something. This is 1.3, this is 7, and then over here is 13. 13 is under 8. So 1.378. Let me just double check. 1.378. Why is there a negative sign? Because the rule for back solving, that is using the probability, that is solving. Using the probability to find the z value, what do? We make sure that the probability is at least 0.5. And if z has a greater sign, z value is negative, my bad. So this is z value is negative because of the greater sign. Now over here we have 0.8, that is 0.800. Similarly, we find the corresponding z value, which is 0.842. This time there is a lesser sign. So for back solving, this is positive. We do comparing coefficient, and let me just highlight it a bit. So we take this thing and we equate it to this. Similarly, we take this thing and we equate it to this. And this is the second equation over here. This is the first equation over here. Let me write over here that this is the second equation. And then we solve it simultaneously. I made sigma the subject. I made sigma the subject. Now I'll be equating this thing over here with this thing over here. I equated it. I solved it simultaneously. I find the value of mu. I find the value of sigma. Take care of the accuracy. 3 significant figures. That's how this question is done and dusted. Not over yet. Not over yet. There is a second part. The lengths in centimeter of the leaves of a different type of tree have the normal distribution. The scientist takes a random sample of 800 leaves from this type of tree. How many? They are not asking for probability. They are asking how many. What is the average number? What is the expected value? What is the expectation? Would you expect to have a length between mu minus 2 sigma, mu plus 2 sigma? A very classic question. Remember these values, 68.26% of the distribution lies within 1 standard deviation of the mean. Okay. And if I change it into 2 standard deviation without any calculation, I'll write the answer 95.44%. And if I change it into 3 standard deviation within the mean, the answer is 99.72%, which is almost the whole 100%. Now, this is not calculating mu and sigma. This is working in terms of mu and sigma and doing the cancellation and simplifying it. So mu plus 2 sigma, subtract the mu, divide by sigma. Mu cancels out, give you 0. 2 sigma over sigma gives you 2. Mu subtracts gives you 0. Negative 2 sigma over sigma gives you negative 2. This is rule number 7 according to the way that I've taught in my class. So if z lies between 2 values such that one is positive, one is negative, take the reading from the table. Read the probability. Phi means read probability. Phi means probability z less than a. So read the table for 2, read the table for 2. Subtract this negative, get rid of this negative sign, add up the probabilities, subtract 1, you get this answer 0.9544, not over yet. How many? Expectation, NP, 800 into 9544, that comes out to be 763.52. Whenever we are talking about leaves or we talk about fruits, we talk about apples, we talk about oranges, we talk about the number of people. So always you have this option, either you round it down or you round it up. Both are perfectly fine. Make sure to give the answer in integer. So now this thing is done. Question number 5. It says the times in minute that CAIE spends each day on social media is normally distributed with such and such. Part 1, how many days of the year? Again, how many? They are considering a year to be of 365 days. Would you expect CAIE to spend more than 142 minutes on social media? So X follows a normal distribution such and such. Calculate the probability greater than 142. Standardize. You get a positive value. This is rule number 2. Z greater than a positive value, 1 minus phi of this value, 1 minus this value that you get from the table, subtract 2396, were in 4 decimal places because that is what you obtain from the table. Again, expectation of X, multiply it with 365. This is the answer that you get. This is also acceptable. This is also acceptable. You can round it down. You can round it up. Again, the same thing. Now it's asking, find the probability CAIE spends more than 142 minutes on social media on fewer than 2 of 10 randomly chosen days. Now you are taking the probability of success from normal distribution. The number of trials is 10. X follows a binomial distribution, 10 comma this value, probability X less than 2, probability X less than or equal to 1. So calculate the probability of 0 and 1. Use the binomial formula, add it up, give the answer correct to 3SF. All good, all clear? Whenever you need something, just pause, take a screenshot, and definitely jot it down in your register. Don't expect miracles to occur. Keep that in mind. Now, on 90% of these days, Kali spends more than t minutes on social media. So probability x greater than t is 90. Probability z greater than the standardization t minus 142 over 24 is 0.90. From the strip, read of the value for 90%. That comes out to be 1.282. And over here, let me just change the notification. That's good. So now probability z greater than 1.282 with a negative sign because there is a greater. Simplify, we get 94.2 correct to 3 significant figures. That is the mark scheme. And question 6. In Greenton, 70% of the adults own a car. So the success over here is having a car. It says a random sample of 8 from this town is chosen. Find the probability number of adults who own a car is less than 6. X follows a binomial distribution. 8 is the number of trials. Probability of success is 70%. Less than 6 means lesser than or equal to 5, which is 5, 4, 3, 2, 1, 0. That's so much to calculate. So what we do is that we take the probabilities for 6, 7, and 8, add it up, and then subtract from 1. And this is the answer that you get. Work in at least 4 SF. Even if you work in 5 SF, there is no harm. Final answer, 3 SF. If you are using this answer in the next part, use the unrounded value. That's a rule that have been taught from you, that have been taught to you, not for you, from IGCSE and O-level maths and edXL and whatever board that you're doing. A random sample of 120 adults from Greenton is now chosen. Use an approximation. Which approximation are we talking about? In S1, we talk about normal approx. Find the probability more than 75 of them own a car. So now this value is changed. This probability of success is the same. Probability of failure is 0.30. Whether the examiner asks or not, I have a habit of doing justification because I don't aim for a simple grade. I aim for an A star. So I would like to tell everything to the examiner, which means that that is what I'm teaching you. That is what you are supposed to do. So now N is 120, P is 0.7, Q is 0.3. Calculate NP, which is mean. Calculate NPQ, which is variance. Calculate NQ, which is nothing. It's just used for justification. Since NP is greater than 5, NQ is greater than 5. NP is greater than 5, NQ is greater than 5. Therefore, X follows a normal distribution. Take the mean from here, take the variance from here and write it down. Then in approximation, don't forget CC. What is CC? That is continuity correction. So you cannot use this value. That's out of bounds. Either use the upper bound or the lower bound. Since this value is not inclusive, choose the next one, which is 75.5. Standardize, subtract the mean, divide by standard deviation. Keep in mind, this is variance. So what goes over here? Square root of variance. You get this Z value, Z is greater than negative. That's the same thing as Z is lesser than positive. Read directly and then you get this answer. And that is the mark scheme over here. And that's it from my side. So that was a comprehensive test of representation of data. And it was about normal distribution, everything, anything related to normal distribution and representation of data was asked. Naturally, I did not ask CF over here. I asked histogram. That means CF, maybe the examiner could give you CF, maybe the examiner could give you histogram. Similarly, I asked for a stem plot. So maybe the examiner can give you a stem plot, ask for a box plot. So these are the different possibilities that could be there. When we talk about mean and SD, I asked you a question related to coding. Maybe there is a possibility that you can have a question related to sigma x square for men, sigma x square for women, and you have done all these questions in class. So there are so much variety in it that you should focus on your concepts in and out. And summary sheet. And in one of the reels, I've just talked about active recall. How should you use active recall? So make sure that your grades goes all the way up, all the way to an A star. That is what I'm trying to do. That is what I'm trying to achieve. Take care, everyone. Stay tuned for more content.